Hi there, this is session 24 of Programming from the Very Basics using Python. In this session, we will continue with our journey on sets. I think I introduced you about the set collection in the previous session. I told you what are the different operations you can perform on them. And this will be a continuation for that previous session. And I'll talk more about sets. And also, if time permits, I will also give you an overview of a dictionary. So let's get started. In the previous session, I told you how you can construct a set. Three forms of construction: the literal notation, the constructor expression, and also using set comprehension, which can be like a map or a filter. One of the things I forgot to mention in the previous session is creating an empty set. You might think that when you create a set like this, there's a literal notation. So if you try to print A and print type of A, it's indeed a set. But maybe you want to create an empty set. You might be tempted to do it this way, especially if you come from the Python 3 world. And to your surprise, this does not create a set, but it creates a dictionary. There's a reason behind it. The curly braces was earlier used to represent a dictionary. It's only in Python 3 that the same curly braces was also used to create a set. Now, if you want to create an empty set as such and not a dictionary, you won't do this. Rather, you have to use the set constructor itself this way. And this is a correct way to represent an empty set. You have to make a note of this. In fact, whenever you print a set that's empty, it prints as set open close parenthesis rather than printing it with empty curly braces. Because when you try to print, when you print an object and the string representation object shows up as empty curly braces this way, is very likely an empty dictionary, right? So that's what you should know. And coming to the features, I talked about a set. I told you can apply a couple of operators on a set. One of them is the minus operator, which is used for set difference, where you can check the difference between the left-hand operand and the right-hand operand. What elements are there in a set passed as left-hand operand versus what is there in the right-hand operand, right? You can use set difference, and I told you about the pipe operator to use set union, which does a set union, and an ampersand operator, which performs a set intersection. I also use the caret operator, or you can call the cap sign, which is used for symmetric difference. You can also compare sets in terms of subset or superset relationship using the less than and greater than operator, which I'll just show you. Suppose I create a set here. Let's say A is equal to some random numbers again. And B is equal to another set, which got something else. Some numbers match, some numbers don't, I believe. I guess so. Oh, I think every number is okay. Yeah, we can just check this. Looks like all numbers are there. You can see 54 is there, 23 is there, 12 is there, but 76 is not there. 43 is there. How do you check that? You can just check by using B less than A. Greater than false. This is a subset check. Check if B is a subset of A. You could also try this out. Maybe I can create another set, let's say C, which has almost all the values in A, let's assume. Let's try 54 and 89 and 12 and 78, for instance. And now if we try it, C less than A, it shows true, which means all the items of C is there in A, right? So you can use print here to print all these things, and let me make those adjustments. You can also do a superset check by using print A greater than B or A greater than C. Check if A is a superset of B and C. And this is how you see it. So you're going to check for subset superset relationship between two sets. You can use the less than and greater than sign as needed. All of these methods are also available in their augmented form. Not all of these. I don't think the subset superset is available in that, but maybe the union, the intersection, and the symmetric difference. All of these are available, and also all the difference, right, is available in augmented form. For example, if at all I have a set that, I'll just bring these two sets again. If I try doing A minus B, it shows all the items that is there in A that is not there in B. But I can actually do this. I can actually say A minus equals B. If I type A minus equals B and try to print A, it only maintains the differences. All the common elements are removed. Right? You can see that right there. So all the items that are unique to A and not found in B, that is what is retained. And this will modify the existing set A because set is a mutable object. You can actually see that when I try to print the ID of A before and after the operation, the ID would remain the same. Well, you can see that right here. The set difference can be augmented to modify an existing set. Just like I told you when I talked about a list, the plus equal to operator for a list is an augmented form of the extend method, right? So instead of a dot extend of b, assuming that a is a list, you could also say a plus equal to b. That's for a list. For a set, you can augment most of these operators, which is the minus sign, which is the set difference operator, and also you can also augment the set union. Let's assume that I'll copy this cell again. Hang on a minute, I made a mistake somewhere. What I do? Okay, I guess I got the wrong one. Is it? Yeah, I guess so. Sorry, hit the wrong key. C and V. I think I put a B and V there. All right. You can also perform an augmented variant of the union, which would basically make sure that A will also get updated with all the items of B. This is equivalent to updating A with all the extra elements or extra items that is there in another set, which is B. Right? So this is to update A with all items of B. When I obviously mean all items, obviously duplicate items would be just ignored. The only extra items, I would say, rather than telling all extra items from B. You can also use the intersection variant, just like the union. When you do this, you just say ampersand equal to, and you can see the outcome here. So this is a intersection update. What it means is that, okay, by the way, this is simply called as an update, whereas this is called as a difference update. And you also have a variant, which is the intersection update. And you can see the outcome, of course. What A would be retaining would be only the common elements that are found in B. You have A with a set that is having a lot of items, but then you have another set which has got some extra items, and you want to, based on the common items that is there in the other set, you only want to retain those common items, then you can use the intersection update. Think of intersection update as the exact opposite of the difference update, right? That's the way it is. And you also have a symmetric difference update too, where you can use the cap sign, cap equal to B. There's a symmetric difference update. To tell you the truth, I don't know if I've not used all these extraneous features extensively, but yes, you will find some corner case scenarios where these could be useful dealing with collections. Sometimes people ask me, all right, all these features are good to have in a set, but I have two lists. I have two lists of numbers. I want to find the difference. I want to find symmetric difference. I want to find the union. want to find the intersection. Can I do it with the list? Well, you cannot do it with the list, but one hack is you can convert it to a set, perform the operations, bring it back to a list. I know it looks a little bit of a jugglery, and I wouldn't use it for really large data sets, but it sort of works. So let's assume that these two collections were indeed lists and not a set like before. And now let's say you want to find out the difference between A and B. What items are there in A that is not there in B? Should I use a traditional for loop and use that B in or item in B kind of a check, which I showed you an example snippet in the previous session? Should I do that, or can I do something else? Well, one of the ways I can do that is assuming that it's a list of numbers. If the items of a list are all hashable items, and you don't care about duplicate items in them, you want to make sure they're unique. So you can actually do a set of A minus set of B. Just construct a set from A, construct a set from B, find out the differences, and you can recreate a list from that set. The only side effect is that the order of items would be lost. But yes, that's what you get. So you can transform maybe a tuple or a list to a set, do the comparison, and then all kinds of operations, all the set theory operations, and you can recreate the list back from them. This would also work for a string if you want to do that. So maybe if at all you might ask me, I have two strings. Let's say hello world, and another string which is test data. What I want to do is that I want to get all the characters that make up these strings in one place. All the characters. I want to see what all characters are there in these strings. So if you want to do that, suppose if I do a set of A, you can see that it's sort of exploded a string, but you can see every character is maintained uniquely. Now you can do something like this. You can do a set of A, pipe set of B, which is like a set union of these two strings, and then you can recreate a string back. But you know what? If you want to create a string from a set, you have to do it just like you did for a tuple. You have to use a join method, because the string representation of a set will be curly braces with comma separated items in the string representation, right? So you might want to use double quotes dot join of set of A, pipe set of B. This would create a kind of I would say a graph, or I could say a data set which says which kind of represents all the characters that make up A and B in one place. They're unique. So you can see hello world and test data together, they're only made up of these characters. So yes, if you have a very large string and you want to find out what all characters are found in those strings, then you can use the same technique. You can just convert it to a set and bring it back to a string, and you just get a shrunken version which contains all the characters that make up that entire textual data. So all of these are some use cases you can think of. So far I told you about all the set operations, and yes, you can compare two sets, by the way. So one of the things is, like, say, sometimes it may not be a set. I'll tell you the more practical use case for this I found was with a list, or maybe with a string, or any other collection, let's say, which are all having items which are hashable. Now let's take an example of a list which has got numbers here in some random manner, random numbers. And I have B, which also got numbers. I have these two lists, and I want to check whether these two lists have identical elements without having to worry about the order. I want to know whether all the items in A are there in B and nothing extra. I want to make sure that both of these lists have identical items, though they are sort of shuffled. And the way you do that, the old school way is people end up writing code like this for item in A, and then you'll just check. You can write some logic like this for item in A if item not in B, and then you could just say print. Sorry, I think I hit the wrong key. Sorry, and say the lists are different. Maybe it's a function you can just return false. Let's assume. Else you could say print. Oh, I forgot to mention this. I put a break here. I forgot to put the break. Break out of it. Else you can say the lists have identical items. Here's an example that shows that lists have identical items, because though you can, when you look at it, it's a little difficult. You have to find out every single item in A and check whether they are cross-verify whether all the items are there in B and nothing extra, right? So if you want to do something like this, rather than writing logic, which I showed you like this, or having your own loop and checking for every single item, one of the other ways you can solve the same problem is you can convert them to a set and compare them. You can also do that simply by using a simple if condition this way. You could just use if set of A equals double equals set of B. When you use an equality operator on a set, we'll check whether two sets have identical items, exactly identical items, and nothing extra on each of them, right? So you can directly check here, telling that the lists are same. I had to flip the condition, but never mind, I'll just flip the print rather. So in comparison to the code that I showed you above, which involved writing your own for loop and iterating over each item in A and checking if that item is not found in B, and then deciding that the lists are different and breaking out of the loop, else, I guess you know this is for else. If you skip that video, just go and watch my video where I talk about compound statements and for and while loop. I guess it's session 6, session 7, one of these sessions. Let's have a look into that, which will tell you the use case of else clause for use with a for loop. And I guess you know this else clause evaluated when the loop runs to completion, but the loop is broken out. If you break out of the loop midway without completing the loop, then this else clause is not evaluated. That's how you decide whether lists are different and they have identical items here. Instead of writing logic like this, you could make it even more simpler if you're able to convert this to a set and compare them. Okay, I would be a little skeptical to use them on lists that are humongous. If you're dealing with lists that's got like several million items, the cost is you're going to create two sets of those million item lists, which will add some will add some memory over it. Do a comparison. Of course, after that, it'll be garbage collector. So you'll have a spike of memory usage for constructing these two sets. That's a trade-off that you get. But then if you're dealing with smaller data sets like these, I think this is more convenient to use rather than writing logic like this. So I'm not going to say the older logic is bad. They work in certain scenarios. If you're dealing with larger data sets with some expense and cost, for smaller data sets, I guess the second one would be more apt. So this is how you can check whether items are identical or unique in two collections. It could be a list. This can be even a string. I want to check whether all the characters in a string are found in the other string, assuming the strings are shuffled, right? You can do all this kind of tests with a set. So I covered all the operators on a set. A set has a couple of methods that you need to know about. First of all, most of these operators that I talked about are also available in the method format. For example, if I go back and try to use these old sets which I had here, this one. You can either print A pipe B, or you can also say A dot union of B. They both will give you the exactly same outcome. The dot union method is just a method variant of the pipe operator. It, I guess, is there for legacy reasons, I believe, in the very old versions of set that existed in the Python 2.4 or 2.5. I think 2.5 is when it was introduced. I need to verify that. It is available as a separate library at the time. You need to say from set import set, and they had methods. like union, intersect, and all that. But later on, when they got inculcated as a part of Python built-in types, the operators were added to them as a better equivalent than calling methods. So you can use union even now like this. Instead of typing a ampersand b, sometimes people use a intersect of b. You can see the outcome is same. I'll type a, instead of typing a minus b, you can also type a dot difference of b. And instead of a dot symmetric difference of b, oh sorry, symmetric difference is equivalent of a cap b, you see here. And I think it's called not intersect, it's called intersection, if I'm not wrong. I can figure out because the highlight was different on my VS Code. Sometimes these things are good. And of course, you also have the variant called difference update, intersection update, union update, and symmetric difference update. They're all the augmented variants which will modify the existing list, right? So you also have the other variations that you can think of. So you can just see the outcome is exactly similar. You can either use the operator. I would prefer using the operator. It's more convenient. But there are some rare use case scenarios where you might want to refer to those methods. If you're writing some functional programming logic, which I'll discuss when I talk about functions, you might want the method variants. You can use it there. You can use them there. The next feature I should talk about is the obvious the other methods which I should talk about for a set are set.copy. I guess you know what this does. This will make a duplicate copy of a set. I talked about list.copy, remember? Set.copy. I'll just call this as maybe something else. Maybe I'll just call this A1, for example, in this case. And if I try to print A and A1, print ID of A and ID of A1, you can see the difference. Their contents look identical, but you can see there are two different objects because the IDs are different. That means it creates a replica of a set. That's what copy does, just like a list. Then another method similarly, if at all you want to empty a set, just like you clear a list by using list.clear, you can also empty a set by using a.clear. I'll print A, and then I could type a.clear and print A. You can see that. An empty set is always shown up as set, open close parenthesis, by the way. So these are some of the methods that you should be aware of when you are dealing with a set, right? So obvious methods that I talked about. But I told you a set is mutable. So how do you add new items to a set? How do you modify a set? Some of the modifications are done by the augmented operators. You can say set pipe equals, set ampersand equals, set minus equals. What do? They modify the existing set based on their comparison with another set passed as one of their arguments. Just one moment. So much similarly, if at all you want to perform other things, let's say you want to, let's say, add new item to a set, you can do that. So you append to a list, you insert to a list. When you use append, insert, or extend, you're trying to decide where you want to insert, or you want to add it to the end, and so on. With a set, there is no position. There is no index or position. You just throw items into a set. So the way you add new items to a set, let's say this A is an empty set right now. So if you want to keep adding items into a set, maybe you want to get it from user input and accumulate values in a set. I can do that by using a simple loop like this. I can say for v colon equals int of input of enter a value or 0 to stop. It's going to keep prompting input from a user for a value, and whatever value that the user types as a type, that'll be, I want to add that to a set. To add it to a set, you could just use a dot add. Simple. A dot add of b. And I can just print the value of a. I made a mistake here. So f must be outside. Ultimately, I'll just print this one more time outside the loop. So if I try running this by pressing Control Enter, you can see that it prompts for user input here. It's VS Code, right? So you can say enter a value of 0 to stop. Let me start adding numbers. 10, 34, 23, 89, 56. I think if I scroll down a bit, you can see this the set, right? It's getting updated with all the values I'm adding. You can watch it while I'm adding. Let's say I'll try 45 again, 45 one more time, 45 one more time, 45 one more time. You don't see any changes because duplicate items are ignored. When you do an add, only as long as the items are unique, it'll be added into the set. But if those items already exist, it's going to ignore it. There'll be no change into the set. So you can put 100. I can see a new value got added. I think 100 went there. So every time I'm adding a value, you can see it goes in different locations, right? When I put 100, it shows up in the second position here. And if I try to add, let's say, 110, it goes elsewhere. It goes here, right? And to say I'm done, I can just type 0. This exists a loop, and this our set got accumulated with its values. So you can add items to a set by using add method. If you want to remove an item from a set, you can use the remove method. You can say a dot remove of a specific item. I'm just going to print a and print a after that. You can see that I said remove of 100, so 100 got removed. Remember, there's no such thing called removing multiple occurrences because there could be just one copy of 100 in a set. There are no duplicate items, right? So you do remove, it's just going to remove that only item that is there in a set based on its value. But the problem with remove is that if you pass an item that is not there, that doesn't exist, it will raise an exception. Let's say I copy this cell one more time and I run this one more time because I'm going to run print A, which is going to print, don't worry about the output, there's an old output. But when I say dot remove of 100, this A does not have 100 anymore. But if you try to remove an item that is not found, you will get an error. And you get an error called key error. This looks very reminiscent of a dictionary. You can assume that every item in a set is like a key, but it does not have a corresponding value. You'll see the relation between a set and a dictionary in a while when I talk about that, when I introduce you to dictionaries. But you can see remove works as long as the item exists in a set. If this item is not there in a set, it will raise a key error exception. It does not raise index error because there's no index in a set, right? You don't have 0th item or first item or so on. So it has to raise a key error. It can't be called as a value error. They say set is just a collection of keys, not collection of values. That's how the official definition is sometimes. So that's the reason why they have this key error. In fact, traditionally, even today, I think in many languages, a set is technically a mapping, but without their values being exposed to us. At least I know in Java, back in the days when I used to read Java collections, they say, oh, a set is just a modification of a map. It could be a hash map, for example. If there's a hash map, there's a hash set. If there's a tree map, there's a tree set. There are different implementations again. They're all the language design. And think of a set as only giving you access to the keys of a dictionary where you don't have to worry about the corresponding values. So that's what it is. In fact, in the very early versions of Python, it was the same case. But now, since Python 3.6, the set implementation and dictionary implementation are separate. That much I can tell you. The dictionary is being re-implemented in Python 3.6. So the underlying implementation is different. But for large part, keys of a dictionary work pretty much like a set, apart from just one thing about the unorderedness. We'll discuss that later. So remove raises an exception. But there are times where you want to remove an item from a set, but I don't want it to raise an exception if the item does not exist. On such occasions, rather than using remove, you can use a method called discard. Discard is just a convenient variant of remove which does not raise an exception if the item does not exist. So in this case, you try to remove 100, it's just going to ignore. But however, if I just say a.discard of Let's try 45 because 45 exists. That's going to be removed, right? So the discard is just like remove, but it does not raise an exception if an item does not exist. That is a difference, right? Sort of like the find method versus index method in the on strings, right? Find does not raise an exception. It returns a special value -1 when you're searching for a substring. Index raises an exception, right? It's a similar pattern, a similar variant, that variation that you see in relation with remove and discard. I told you how to add an item into a set, one single item, how to remove from it. If at all I have an existing set and I want to store all the items of an existing set into another set, you know how to do that. Update. And update does nothing but, if at all I want to update one set with another set, let's assume that I have another set here. B is equal to 100, 200, 300, 400. But I want to update, A with all the items of B. A is what you see above, right? Here, the last version of A, I would say, last update of A, right? You can see that. So if at all I try A dot update of B and then print A, can see this. But you know that this update is nothing different than A pipe equals B. It performs a union. Takes a union into the current set and updates the current set. That's what it does. So you can also say, you could also have typed, I'm just going to leave it as comment here. Also, A pipe equals B would work. Let's see. These are the different methods that you should be aware of when you're working on a set. And yes, last thing I should tell you is that even the subset and superset methods, I think I put this right here where I talked about all the methods and their operator equivalents. You can also do this. You can actually do, instead of doing a less than B, you could use a dot is subset of B. It's all the same. Or instead of doing a greater than B, you could also type A dot is superset of B. So most of the methods that you see in a set are all sort of redundant. They're just the method equivalents of their operators. The method variations exist for legacy reasons. So ideally you should be using the operator if you can. But there are very rare scenarios where you want to call out by their methods. If you're using in functional programming logic, you want to just refer to the method which will be passed on to a higher order function. Don't worry about all these jargons. I will talk about that when I talk about functions in the second part of functions, right? But now, these are the different methods you should know about. And let me see if at all I missed out any methods. If I just type, let's say, A dot, and you can see that add, clear, copy, difference update. There's nothing but the minus equal to equivalent of minus equal to, right? Discard, intersection update is like ampersand equal to, and is disjoint, checks whether the set is a disjoint set, right? That's another method you can use. And is subset, is superset, and you have pop and remove, and you have symmetric difference and difference update. So these are the methods that you should be aware of when you're working on a set. More often, you'll only deal with these operators which I just mentioned. The only methods that you'll mostly need to know is add, remove, and discard. For every other methods, there are operator equivalents that you can just directly use if required. This pretty much sums up all the things that you should know about a set. And now let's get on to dictionaries. Dictionaries, I have already introduced you what dictionaries are. I make a note here. A dictionary is a collection of key:-value pairs where keys are unique and hashable. This is what the definition would be from Python 3.6. But before Python 3.6, dictionaries were also unordered, just like a set. So when you create a dictionary of key-value pairs, in what order you create them, the order is not guaranteed to be retained. So there used to be something called as an ordered dictionary found in the collections module. It's there even today for legacy reasons. But you don't need to use it because the dictionary by default from Python 3.6 has been re-implemented to maintain the key value pair ordering. The keys are ordered, which means that in what order you create a dictionary, the same order is maintained by Python. But though it's ordered, it doesn't mean you can access based on their indices. Unfortunately, that's not what it's meant for. The subscript operator doesn't give you that feature. But you can do a lot of other things, like you can assume the order when you're reading over it, and that's one of the benefits that dictionaries provide. Now, there are many ways you can construct a dictionary. The first three obvious ways, much similar to how you'd construct other collections, which I covered so far. You can create a dictionary by using the literal notation, where you can use open curly braces, and then maybe you can type any key. The key can be any hashable object. So technically, you can have a number as a key, you can have a string as a key, you can also have a tuple as a key, assuming the tuple is hashable. But what is commonly used is a string. That's why I use a dictionary. It's a very, very unlikely scenario where you want to create a dictionary where you want to have numbers as keys. If you have use case scenarios where you want to use numbers as keys, and you might seriously want to think of using a list instead. But maybe the reason why you want to use numbers as keys is because you want to have something like an associative array that is found in some languages. PHP comes to my mind. TCL also comes to my mind, where the indices are sort of not very contiguous. So when you create a list of 10 numbers, the indices will be 0 to 9. It's contiguous, right? 0, 1, 2, 3, 4, it goes on all the way to 9. Maybe you have some kind of a data structure where you have some gaps. Right? In such cases, you can use a dictionary and have the keys as a number. But I would still recommend using a string, if you can. And though you can use a string, which can have any characters, if you want Python to sort of perform its word string optimization on your dictionary, I'd always suggest from the performance standpoint or the memory optimization standpoint to try and use keys which are word characters, which are made up of word characters. Keys that are made up of single word is generally preferred, but it's flexible. It allows you to have any string that you want. So instead of you can have a key that says first name like this, but the string called first name, right? If you end up having, let's say, multiple dictionaries like this with the keys first space name, there'll be multiple copies of the string in memory because each of these keys are ultimately string objects. So if you have, like, say, 100 dictionaries and all the 100 dictionaries have something called first space name, this happens if you represent a record as a dictionary and you have 100 records, right? In such cases, this may not be very optimal in terms of memory. So when you believe that your dictionary is going to be having multiple copies of them allocated, like a record, multiple records, then try and see how well you can optimize it. And one of the things I would recommend is try and avoid spaces or any special characters in their keys. Though it will work, it's for performance optimization or memory optimization, you can actually use word characters like this. So for now, I'll use a simple dictionary which represents some data. Let's assume some random data. Let's just take, let's say, name, John, and role, developer, and company. Let's say I put my official company name, that's /blog, and let's say experience. I'll say 10. So this is one of the ways you can create a dictionary. This is called as the literal notation. Though you can create dictionaries like this in a one-liner, if your dictionary's just got one or two key value pairs, then it's okay to have in one line, but you still have an option to nicely format it. So if at all you want to format your dictionary, I would recommend you to format it like this, where you open curly braces, then you can actually have them all in this particular format. Here the spaces here doesn't matter. It's free form. The moment you open any brackets, be it square brackets, parentheses, or curly braces, and you have comma separated items in them, you can span it to multi-lines and format it the way you want. So you can format a dictionary like this. So I'll give it this way. There's a little rotation, though I expanded multiple lines. And you can also create a dictionary that can be done using constructor expression, where I could say A is equal to create a new dictionary of name equals John. This is how you construct a dictionary by passing keyword arguments. And role is equal to developer. And company is equal to /prod. And experience equals 10. This is another form of constructing a dictionary. And of course, instead of having it in one single line, I could actually organize it nicely indented this way. Dict is a constructor. So I'm using parentheses, dict parentheses. And one close observation, this is a keyword argument. You can see there's no quotes. I said name is equal to John. So there's a small limitation, I would say rather. If you're constructing dictionaries like this, it expects you to have word strings. It has to be a string. You can't have a number here. You can't say maybe if you want to create a dictionary that's in a literal format, you can have anything as keys. It's like things like, say, maybe you could just put 10. You could say 100 colon 200. Perfectly fine. It's going to work. There's a key called 100 whose value is 200, right? That's perfectly allowed. When you use literal notation, it's more free form. When you're using a string as a key, you can have any special characters. Let's say you could use phone number like this. I have a hyphen there. That's perfectly okay. And I can have some number, let's say, whatever, randomly add a number there. Maybe make it look like a phone number. I can just put some hyphens in between. Yeah, whatever. It's not a valid phone number. At least I don't know of a phone number like this. So you can see I use hyphen here, or you can use spaces or special characters within a string, and it'll just work fine. And you can also use a double. But when you plan to use constructor expression, see this works, right? No problem, right? You can print A the first time, or you can print A for this too. No problem, right? But when you're using a constructor expression, it expects the keyword as a single word. I mean, that will act as a key. See, John. Name is John. Sorry, name, role, company, experience. Try putting something like, say, 100 equals 200. Python will get totally confused, and you'll get an error. It's a syntax error. You can see that? It's a syntax error. It doesn't work. Even if you try to provide something like phone number is equal to some number like this. It'll throw an error. You can see this expression cannot contain assignment. Perhaps you meant double equal to or something. It thinks the syntax grammar checker thinks it's some kind of expression that you put on the right hand side, in the left hand side, right? You put phone minus number in the left hand side. It assumes that. So it's all treated as a syntax error. So there are certain restrictions, I would say rather, if at all you're trying to use the constructor expression to create a dictionary. But I'll tell you what, if you're able to construct a dictionary using the dict constructor, that dictionary is going to be very optimal, because obviously I told you every key will be a single word, and that looks like an identifier word, and that will go to the word string interns, and they will be optimized if you have multiple records of the same type, multiple dictionaries with similar keys, right? That's the thing they should know. I'll leave this version here, and to show you that what works and what does not work. Another interesting difference I found, different based on the difference between the literal notation and the constructor expression is that apart from the restrictions on how you can formulate keys when you use a constructor expression, um, keys cannot repeat when you use a constructor expression. See here in the literal notation, what if I again type name and say Alice? A repeated name here. The same key is repeated twice in the literal notation. This has no problem. The last key value pair mapping will clobber the previous key value pair. I use the word clobber. That means it's just going to override that. I'm not sure if the override is the right term to use. Sorry. So it may not be the right term. It's an object-oriented term. It's something else. But basically, name was mapping to John. Now, when I say name colon Alice, name now gets to map to Alice, no longer John. That's what happens. But try the same thing with the constructor expression, where it again type name equals Alice here. And this will raise a runtime error. Sorry, it's a syntax error. You can see that? Keyword argument repeated. It's a syntax error. Right? Strangely, it executed the previous print, though it's a syntax error. I'm surprised to see that. Okay, I think it's old output, perhaps. So you can see it's a syntax error here. Invalid argument, keyword argument repeated as such, says that. So it is a rule. Python sees this like a function call. It's like you're calling a function passing keyword arguments. When you call a function passing keyword arguments, the keyword, the part of the keyword argument should not repeat. That's a rule. And that's why it threw a syntax error. So these are some restrictions you'll have if you plan to use the constructor expression to create a dictionary. But I still prefer using a constructor expression because those restrictions are good, because it lets you create a dictionary that is less ambiguous, and it has the chance of being better optimized in memory because you're using keywords which will be optimized using word string interns. So that's one of the things. And even typing it is easier. In my opinion, this requires a lot of painful shift operations, right? Now, shift double quotes, or some of you might use single quotes, is fine. But if you plan to use double quotes, shift double quotes, shift colon, which you cannot avoid. So you have lesser travel to shift keys. So you might be able to type this out faster if you're a touch type kind of a person. So that's a convenience with using the dict constructor. You can also construct a dictionary using the comprehension, which I'll show you here. This is called as dictionary comprehension. And how do you do it? I could actually type A is equal to create a new dictionary. You can't use a dictionary constructor here. That's a small limitation. Last time I checked it, it threw an error. It didn't work. Right? So you need to use curly braces. If at all you want to construct a dictionary using a comprehension expression. Otherwise, if you want to use dictionary constructor, you have to create a tuple set. That's 2-element lists and pass them out. I'll talk about that later. So I can use dictionary comprehension like this. I say A is equal to open close curly braces. And here I can type key colon value, K colon B, to indicate key colon value for, oh, not key colon value, I made a mistake. It's a key, I'll just use a X colon X into X. Okay. For X in range of 10. Now try to print A, you can see this. So what this does is, the for loop part of it, the for construct here, the for expression, iterates over each item of range 0, 1, 2, 3, all the way to 9. And that is represented as X. And that is also stored as a key. And the corresponding value is that key multiplied by itself. So store X as a key and X into X as value. So 0 maps to 0, 1 maps to 1, 2 maps to 4, 3 maps to 9. So you have a nice dictionary. It looks like it has indices and also the actual values, which are squares. But you can also construct a dictionary yet another way by passing a 2-element tuple set. The word tuple set does not mean it's a set. It's a collection of equal size tuples. It can be any collection or any iterable of equal size tuples. If you have a two element tuple set, then you can construct a dictionary out of it where one of the items will act as a key and the other one will act as a value. Let me demonstrate that here. Let us say, for example, I will just use, maybe I can. Let's take this. Let's take, let's say, players equals John, Sam, Alice, Elisa, Damien. And then let's write scores equals some numbers. 45, 67, 78. Oh, yeah, it's 87. Okay. 23 and let's say 50. Some numbers, some random numbers here. I told you in the previous sessions when I talked about iteration helpers, I could use zip of players, comma scores, and just create a zip object. If you want to see how this ingredients would look like, you can always construct a list and see it. Maybe a list or a tuple, it doesn't matter. And you can see that when you iterate over the zip object, you get two element tuples. So this pretty much is like a two element tuple set. So having two collections, it could be two lists. I want to treat all the items of one list as the keys and correspond to the items of the other list as their values. And I can create a dictionary out of it. And I can do that pretty much by using this technique. I'm just going to use print here to print what it shows up like. Okay, here. That's a zip object from which I constructed list, but I can create a dictionary by using D is equal to create a dictionary out of zip of players, comma scores. And this works. So all of these are the ways you can construct a dictionary. I told you about the little notation. I talked about dictionary comprehension. Constructed expression first with keyword arguments, dictionary comprehension. But you can also use a constructed expression passing two element tuple sets, where one of the items act as the keys and the corresponding item would act as values based on what you see here. So these are the ways you can construct a dictionary. I will talk about all the dictionary methods and all the dictionary operations in the next video. But before I close down this video, I should tell you something about a set, which I forgot to mention. Sorry about that. Flow, right? It's all in one video though. I told you how to create a set and I told you all the different methods on a set and I told you various operations. You can look at a set as a very advantageous and very useful data set, a very useful collection, right? It's a very useful collection. But then there are certain limitations you should be aware of. To begin, sets take up a lot more memory than a list. Set consume more memory than a list. So if you're going to create a set with a lot of items in them, you got to be a little careful about their memory usage. They can be a memory hog. If you're going to create a set of millions of items or maybe hundreds of millions of items perhaps when you're dealing with huge data. So I'll just show you the example here. I would have mentioned that you can find out the memory footprint of any object by using sys.get size of, right? So I can use import sys. Let me create a small list, maybe a list of 1,000 numbers. It's not small actually, 1,000 numbers, but still it's small for the computer's memory. So if I just try, A is equal to list of range of 1,000. And if I try to do a print of, I can use maybe I'll use a format string right here, sys dot get size of A equals. So I'm just trying to print the output of sys dot get size of A. So sys dot get size of will let you find out the size of a given object. I think I covered that in the previous session when it's trying to cover about integers, right? And told you integers are arbitrary length and I told you about size and all that. So you can see this is a memory footprint of a list. Let me tell you about a list. If you try to create a list that's absolutely empty, let me try with the empty list here. The minimum size of a list on my machine with the current Python implementation is 56 bytes. I guess the size can vary based on your Python build, on what architecture or what machine you're running Python on, Windows, Mac OS, maybe, I don't know. I had to verify that. It could be implementation dependent and also version dependent, of course. I remember back in the Python 2 days, it was a little bigger. It used to be about 76 bytes on my machine in Python 2, but with Python 3, they reduced the size a little more. So the default size of an empty list starts off as 56 byte. And now, if at all I create a list of, let's say, 100 values, range of 100. What do you see there? 856. Let's make it 1000. 8056. Let's make it 10,000. 80056. Let's make it 100,000. You see, it all goes in the numbers of 8 here, right? The point is, for every value that is stored in a list, every item that is stored in a list, not value, every item that is stored in a list, the list actually has a pointer of 8 bytes. So it's creating an array. It's creating an array with 8 byte pointers. For every item, 8 byte is allocated within a list to represent the item. The actual item could be somewhere else in memory. So here, this only tells you the size of the list, but not the size of all the numbers that the list represents. You should note that, right? There are numbers, right? There are numbers like 100, 200, 300, 400, all these numbers. They're all independent objects. They're all integer objects. You have to take into consideration the size of all those objects created. You have to sum them up plus the size of the list. This only tells you size of the list object, not the size. It will not sum up the size of all the items inside the list, right? That's something that you should note. So if you get a list of strings, which are very large strings, sys.getSize of A will tell you the size of the list. It does not sum up all the sizes of the strings inside them, because the list only holds the references to them. It doesn't store those strings, right? You have to calculate the size of each string, sum them up, and then add with sys.getSize of the list to get the total size of the entire data structure with the data. That's something that you should keep in mind. But for now, I told you the list grows based on 8 byte pointers because I'm running on a 64-bit architecture. That gives you answer. You can see it shows like I made it like 100,000. So it's 800,000 plus 56. That's the extra metadata overhead that you see here. Even an empty list has 56 bytes, right? Yeah, forgot to mention this. I should have covered it when I talked about missing bits in numbers. Sorry about that. When you have numbers which are quite large like this, in Python, in all the modern versions of Python, it looks not very readable. So at a certain glance, I don't know whether it's 100,000 or 1 million. It's difficult, right? So you can actually separate them with underscores like this. It's not unique to Python. I guess most of the modern languages I have come across, they support this feature. So if you want to represent 1 million, I think I can put one underscore. Now this looks like 1 million. Ideally, in the human world, we use commas or maybe dots in some countries, I heard. I don't know. Maybe dots. I don't know that. But I sort of heard about it. But it's commas. In India, we put commas in a different notation. Maybe the British notation, I believe. We use 3 digits, comma, then 2 digit, it goes on. But the American style is like you have 1,000, million, billion, trillion. You separate them. You can use any format that you want. The underscores that you use within numbers, little notation of numbers, they are ignored by Python compile time. It just treats it as 1 million. Anyways, it's just for human readability. You can see this. I told you how the size of the list grows when you create larger entries, right? Let's come back to a list of just 1,000 entries. There's a size. Let's say I create a set out of it by doing a B is equal to set of A and then print this. Oh, I'm printing the size of A here. I'm printing the size of B, sorry. Look at the size of the set. It looks like it's at least 4 times larger than a list. You see that? A list is roughly about 8 kilobytes, but a set is 32 kilobytes, close to 33 kilobytes. So if we try to increase it, yeah, it's roughly 4 odd times larger, at least 4 times larger than a list. Again, this could vary across Python version. In the early versions of Python, it was much larger than this. It used to be almost like 5+ times larger, but now you can see it's at least 4 times larger than a list of the same size. A set does take up more memory, right, by default, because of the hash buckets and how those hash buckets are allocated. They allocate a larger size hash buckets, and there are gaps in the middle. They all take up memory. And one of the challenges I faced in production, in my consulting, I used to do a lot of consulting work. There were issues where my customers or my clients used to tell me that the Python code that's running for a fairly long time used to lead to memory leak. And they thought the problem is with the runtime. When I investigated, it was not the runtime. They were using set, or they were using dictionaries rather, which sort of are extensions of set back in those days. And you will also see the same kind of problem, I guess, in the newer version of dictionaries too, but it's a problem with the set mainly. When you have a set, let's assume that I create a set right now, which is empty. A is equal to empty set. So I'm going to print the size of this empty set now. Sys.getSize of A equals. You can see that the size of an empty set itself is 216 bytes. Remember, the set is absolutely empty. Yeah, it does store more information, I guess, in the metadata. That's a metadata overhead. But as you update the set with more items, the set will grow. For example, now I'm going to update the set, the existing set, right? So I'm going to just, to be safe, I'm going to print ID of A to show this it's the same set. Like this. Oh, what really went wrong? Oh, I forgot this. Okay, silly mistake. I forgot to close this. Close the curly braces. I was wondering something is off there. Okay, yeah. This is the ID of the set and the size of the set. The set is empty. Now what I'll do, I'm just going to do a pipe equal to. It's like update. This is how you do update. You can say a dot update, but you can say a pipe equal to. That's union update, right? Equals. I could use maybe I'll update a set with another set apparently. So I'd use set of range of. Let's try just a range. Let's see if it works. Range of 1 million. You can see that, see, unsupported operands, set and range. So all these operators that you apply in a set, the other operand must also be a set. Obviously, you cannot add a set or union a set with a list. You have to create a set out of it. I forgot to print the size of it. I'll just have to repeat this statement. After this. Of course, with 1 million items being added, obviously the set has grown larger, right? It's grown larger. And I'll also do one thing. I'll also print the length of the set. Len of A equals. Initially, the length will be 0. And this time, I'm going to print the length again. So you know how many items are there. With 0 items, the size of the set is 216 bytes. With about 1 million items in it, the size of the set could be about, I guess, roughly 32 megabytes. Yes, roughly around 32, 33 megabytes that you can see here. Now I'm going to remove those items. I'm going to remove them manually. One of the ways I can do that is I want to write a loop, keep removing one item at a time, all the million items. I'm going to remove that. Okay, so I'm going to write a loop. I'm just going to use for underscore in range of 1 million. Well, I want to remove all the items of the set. I could do it like this, but okay, that's fine. It's just thinking of a more optimal algorithm, but never mind. I'll show you that later. Say underscore in. And I guess you know why I'm using underscore here, because I don't really care about this variable. if you want to have a don't care about kind of a variable which you're not going to use inside the loop, just want to perform some statements this many number of times, you don't care about that variable, use underscore instead of names like I and V and so on. That's the common convention in Python, but it's not a rule, it's just a practice. Now I could just use a.pop. What does pop do? Pop just removes an item from a set. Remove will remove a specific item. Discard will discard an item that you pass as an argument. I forgot to mention that pop just removes one item. And whatever item is removed, you can get it as V, just like list.pop. And yes, pop does not take index here. For a list, you can pass an index, but here pop will just remove one item from a set. So I'm going to pop out one item at a time, a million times, and ultimately the set will become empty again. Am I right? That's what it is. And after that, this time I'm going to print the ID of A, size of A, len of A, and to be sure, I also want to print that A itself. So you'll know what is the actual set content. Just closely observe the output. It's the same set, not a new set created. The size started off as 2 and 6 when the set was empty. The len was 0. When I added a million items into the set, and the length was million items, the size had been 33.5 megabyte. Now I emptied the set by removing every single item one at a time. Did the size reduce? It didn't. This is something that you should watch out for. So if you have a set where you're throwing items into it by using add, then later on removing it or discarding them or popping them out, throwing some new items, discarding them, throwing some new items, discarding them, the chances are the set can grow based on more items that you add, but as you remove, it does not reduce the memory utilization, it remains that. It's like some of these balloons. You blow a balloon, it just expands. And when you release it, it contracts back. But imagine some bad rubber, or the balloon is not made up of a good material. I've seen some of them. You blow the balloon, it expands, and release it, it does not contract back to the original size it used to be earlier. And that's exactly the problem that you see, right? That's in real world. That's a real world analogy. But I'm trying to tell you that the memory is not released back. And this will be reported as a memory leak in a long running application. This is the same problem that you'll encounter even in a dictionary. So you keep popping out items of a dictionary and you keep adding items into a dictionary and you keep popping them out. You keep doing that. The dictionary can tend to grow in memory usage over time and never reduce. But interestingly, I realized there's a hacky solution that is available. So if I empty the set like this, right? How do you really empty a set? Not like this. You would do it with, if you want to completely drain out a set, completely remove all the items. You can do you don't need a loop like this. You do a.clear. If you use the clear method, however, you can see the set regained its original size. But you don't use clear method and drain out all the items at one go, but you remove one item at a time, your memory is not reclaimed. So that is something that you should watch out for. Workaround, avoid this kind of operations where you keep growing a set over time and removing items lesser. That's a symptom, right? You keep growing, removing it, growing, removing it, growing, removing it, removing items. But then overall, the memory usage keeps growing higher, right? Let's say you add 2 items, remove 2 items, add 2 items, remove 2 items. It's okay. But you add 2 items, remove 2 items. Now add 4 items, remove 4 items. You add 10 items, remove 10 items. You can see a dictionary is growing now. The set is growing now. And this can lead to something that seemingly looks like a memory leak. A memory leak is a scenario where an application is just using up more memory and not releasing it back to the operating system. And the OS thinks that this application is badly designed, it's just leaking memory. And eventually the operating system will run out of memory, and that can cause a problem. So this is a known problem when you're dealing with dictionaries and sets. And the pattern that causes it is frequent add and remove operations, which grows this over time, grows the list, grows this dictionary or set over time. Workaround is periodically, it's not going to be a performance optimization in any case, it'll lead to performance drawbacks, is you recycle the set. So maybe instead of when you're doing this error pop, error pop, error pop, at some point you might want to periodically, you might want to just say a is equal to, or you can say a is equal to, create a new set of a. That might solve it. May not be really efficient. If this doing it million times is a bad idea, but I'll show you what I'm inferring here. So here in a loop, I'm removing one item at a time from a set, and you saw that the memory is not reclaimed. But consider this. This could be the worst thing to do. You don't want to do it at every single iteration, but it's just a demonstration for you to show you the effect of it. So, or maybe you can use a condition. Maybe let's say if now I need I, or do I need it? Or maybe I can just do like this. I can just say if length of a set, maybe a length of a set is divisible by, maybe I could say 10,000. Yeah, let's take that ballpark number. It's 10,000. Let's say a is equal to set of a. Or maybe you can say a is equal to a dot copy. That will also work. And it looks like a very weird hack. But let's try this. It takes more time to execute. That's really bad. Okay, let me just stop this. I think I should stop this. Oh, it goes on forever, I think. If the program doesn't seem to stop, taking a lot of CPU, interrupt it. You can interrupt it. But maybe you have to make it, let's say, every 100,000 times. Let's try this. Oh, okay. Is equal to 0. If len of a is, okay, len of a is divisible by 0, right? Len of a is 100,000 roughly. Try this. Yeah, it sort of worked. Not perfect, but it worked. You can see this. Okay, the problem is last time the condition was wrong. I think that was the reason why it was going in a loop forever. So when I did this, what really happened was every time the dictionary reduces by 100,000, that's what this logic is, right? The length of a was 1 million, then it becomes one less than 1 million, or 2 less than 1 million. Once it becomes 900,000, that the size 900,000 is divisible by 100,000, I guess, right? So 100,000, yeah, 900,000 divided by 100, 900 divided by 100, that's it. So it's divisible without, and the remainder is 0. Then you recycle the set. This might have adverse side effects. If you have multiple reference to a set, don't do this. Not a good idea. But this is something that works if you don't have multiple references accessing them, right? So if you have some kind of way to scaffold all the operations, so you don't have other actors who are trying to access the set or dictionary directly, it's like you have two containers, right? You have the containers being continuously being used and reused. Then at some point in time, you take the container and just pour it onto another empty container and discard this off. And you start with this container. Take another container, discard it into another container. You keep doing that. So this is how you're recycling this object. It's a hacky solution, not a good one. There are other problems that you might face with this, but this is what I can think of for this code, right? So I just gave you some example hints, but I would say that you want to fix the symptom. Oh, you don't want to fix the symptom. You want to fix the root cause. This is fixing a symptom. It's a symptomatic fix. Okay, it's a patch. It's a patchy solution. So you find out the root cause of a problem and try to fix that, right? Something that you should be aware of when you're dealing with a set. Much of these concepts are applicable even to a dictionary. We will check with the newer dictionary. I've not really tried this benchmarking a newer dictionary from Python 3.6, perhaps. So maybe things are different. We will find out on that in the next video. So in the next session, the next video, I will talk about all the dictionary methods that you should be aware of, all the dictionary operations and methods, and I will tell you some interesting use case patterns for them. And after that, I'll have another session where I'll sum up all these features related to collection and maybe give you a couple of exercises for you to try out that you can send it over to me on comments. So these are the concepts you should know related to a set and the very basics of constructing a dictionary. I hope you found this video useful. If you do find this concepts covered that I covered or the information that I'm sharing with you valuable, as usual, do hit the like button. And if you're not subscribed, please do subscribe. And I will see you in the next video. Thank you.